Hello everyone, my name is Xiaohan from Virginia Tech, and today I'm very happy to share our work on new dataset and benchmark for causal language understanding in social media discourse. We call this dataset as Causal Talk. It is the first multi-level benchmark that aims to capture not only explicit cause and effect relationships, but also implicit reasoning and human-like gist summarization of causal statements in informal online texts. Causal reasoning is a fundamental part of natural language understanding, but currently NLP research has mostly focused on very form texts, such as news, writing, and some other corpora. With causality is usually implicit and clearly marked as words like because, therefore, or as a result. Social media is different. People talk causally, and they often imply causality without saying it directly. For example, someone might write, I took the vaccine yesterday. I'm really sick now. Even though the word because is not used, the causal meaning is clear. Understanding this type of implicit causality is very important for public health communication, for combating misinformation, and for studying online decision making. But before our work, there was no dataset that supports multi-level analysis, from a simple detection to span extraction and the causal gist generation. This is why we build Causal Talk. The dataset comes from Reddit posts collected between 2020 and 2024 across 43 public health subreddits, such as COVID-19 and debate vaccines. In total, we collected about 239,000 submissions and 19 million comments. From this larger collection, we carefully annotated 10,120 posts. Each annotated post supports four connected tasks. The first task is binary causal classification, deciding whether a post contains causality or not. The second task is explicit versus implicit causality detection, distinguishing whether the relation is clearly marked or only implied. The third task is cause and effect span extraction, identifying which part of the sentence is a cause and which part is effect. And the fourth task is causal gist generation. This is a higher level task where the system needs to rewrite the post in a concise causal summary. For the annotation, we designed two complementary approaches. For the golden annotation, we selected 1,320 posts. Five annotators trained in the causal linguistics and public health labeled these posts independently, and the disagreement were resolved by the final author. For the cell annotation, we annotated 8,800 posts. They were generated using GPT-4o with a special prompt method called role-based incremental coaching. The output from GPT-4o was then verified and refined by human annotators. By combining those two strategies, we created a dataset that is both high quality and scalable. In fact, the self-annotation reached very strong agreement with human judgments, with kappa between 0.78 and 0.89 across all tasks. To establish the benchmark, we trained and evaluated a set of models. For the first three tasks, causal classification, explicit versus implicit detection, In a span extraction, we used standard transformer encoders such as BERT, Roberta, XLNet, DBERTA3, and SpanBERT. For the gist generation task, we fine-tuned text-to-text models such as T5, GPT-2, and BART. We also test several instruction-tuned large language models in few short settings, include Llama, Gemini, DeepSeek, and Claude. For evaluation, we used Prescient, Record, and F1 for classification tasks, Token and span level F1 for extraction, and word score for gist generation. Now, let me highlight the results. For causal classification, the v3 was the best model, achieving an F1 score of 0.87 on all of the dataset. This shows the annotation, once verified by the human, can be just as reliable as golden annotation. For explicit versus implicit causality, performance were a little bit lower. The best model, the Berta V3, only reached F1 of 0.74. This confirms that implicit causality is still a major challenge. Models often misclassify posts that lack explicit markers or linguistic features because they require background knowledge and discourse reasoning. For span extraction, the Bertrand-Stray again performs best with a span f1 of 0.88. However, an error analysis reveals that the model often mishandles span boundaries, either including too much in irrelevant context or missing important words. Finally, for causal gist generation, Fine25 was the best supervised model, but the instruction-tuned large language model like Gemini or DeepSeek outperformed the supervised baseline in few short scenarios. The main problem we observed were that models sometimes omitted the causal relation entirely. Thanks for listening this poster session. If you want to use our dataset, please go to our GitHub repository.